Okay, now we move to talk about, of course, testing for the population mean, uh, when the population standard deviation sigma is unknown. So whenever the population standard deviation is unknown, then of course, how are we going to deal with this? Of course, we're going to use the t distribution. Now, when sigma is unknown, then the sample standard deviation S is used to estimate the population standard deviation. So before, when the standard deviation of the population is known, then the formula of the Z statistic, of course, is calculated by, the formula X bar minus mu over sigma over radical M. Now, since the standard deviation of the population is unknown, then we have to use the sample standard deviation S to estimate the population standard deviation that is unknown. So this is the T, statistic that we will use. Is equal X bar minus mu over S over radical M. Of course, the T distribution has almost the same characteristics as the standard normal distribution. So almost the same characteristics of the T distribution, the same characteristics of the normal distribution. Okay, so we say the major characteristics of the T distributions are: it is continuous distribution like the normal distribution. It is bell-shaped and symmetrical like the normal distribution. As the number of degrees of freedom, which is degrees of freedom n minus 1, increases, the shape of the T distribution approaches that of the standard normal distribution. The T distribution is flatter, more or less. The width of it is flatter than the standard normal distribution, even though it is, standard. It looks like a normal distribution. However, it is flatter. Now, of course, once we are, using the T distribution, we have to know how to use the table that we have to use in order to find the critical values. This is a portion, a simplified portion of the T distribution. Okay, the T distribution, the full, table of the distribution is located in the back of the book in the appendix, which is appendix B.1, B.2. Okay, now this is a simplified portion of the table. As you can see, the far left column of the table is labeled DF, which is degrees of freedom. The far left column of this table is labeled DF, which is degrees of freedom. Okay, here I just put some values of degrees of freedom, of course, and degrees of freedom, as you can see over here, it is n minus 1. Okay, and is the size of the sample. Okay, and 1, of course, we subtract from it 1, and 1 is the sample population. So always degrees of freedom is equal n minus 1. So if the sample size, for instance, is 16, then the degrees of freedom is going to be n minus 1. 16 minus 1 equal 15. So as I said, the far left column of the table is degrees of freedom, is labeled degrees of freedom. Now, of course, to determine the critical value, now after we know that the far left column is degrees of freedom, is labeled degrees of freedom, now we need to know how to find the critical value. To find the critical value, locate first the row with the appropriate degrees of freedom. Say, for instance, we have this example here. Say that, after we, calculated the null and alternative hypothesis, we come up with the null hypothesis, mu less than or equal 100, and the alternative hypothesis, mu greater than 100. okay, and say that the sample size is 16, okay? So we calculate the degrees of freedom, we come up with 15. So now we locate the column with the appropriate degrees of freedom, 15. This is 15 here. This is the column, this is the row that we are looking about. This is the row with the appropriate degrees of freedom, which is 15. This is the row. Okay, then determine the test you are running, whether it is two-tail test or one-tail test. If you look over here, we say that we have one-tail test. Okay, one-tail test. So you look at the portion of the table with one-tail test. It is here, one-tail test. This is the portion of the table with one-tail test. So we move here. Then locate the column with the selected level of significance. As you can see, the level of significance is 5% or 0.05. So where is where is the column with the 0.05 here? Is here. Okay, so what you do here, move down until it intersects move down the column of 0.05 until it intersects the row with 15 degrees of freedom. It intersects over here. So this is what? This is the critical value, which is 1.753. This is the critical value, 1.753. Now, since the rejection region is in the right tail, then the critical region is positive. Then the critical value is positive. Once the rejection region is in the right tail, here is positive in the right tail, then the critical value is going to be positive 1.753. Let's say we take this example over here. In this example, after you state the null and alternative hypothesis, the null hypothesis is mu greater than or equal to 0, and the alternative hypothesis is that mu less than 100. As you can see here, we have a one-tail test, and that the rejection region is in the left tail, in the lower tail. Okay? So now, to find the critical value, we do the same thing as we did with this example. Of course, first, locate the row with the appropriate degrees of freedom, which is here 15. This is the row. Okay. Now, after that, decide whether you have or determine whether you have a one-tail test or two-tail test. We have a one-tail test here, so we move to the portion of the table with one-tail test over here. Then locate, of course, the column with the appropriate or with the selected level of significance. What is the selected level of significance? Is 2.5. That is 0.025. Where is 0.025? Is here. Okay, so I move down this column all the way until it intersects the row with 15, which is here. Okay, 2.131. This is the critical value, is 2.131. Since the rejection region is in the left tail, so the critical value is going to be negative. If the rejection region is in the right tail, then the critical value is going to be positive. Because we have the rejection region is in the left tail, okay, or the lower tail, then we write the critical value to be negative 2.131. Now we solve problems concerning the t distributions. You remember we said we will use t distribution when the standard deviation of the population is unknown. So we begin with the first problem here. Given the following hypothesis. Already the question is giving you the hypothesis, the null hypothesis as well as the alternative hypothesis. H0, H sub 0 is such that mu is equal to 400. H sub sub 1, which is the alternative hypothesis, or the alternate hypothesis, mu is not equal to 400. A random sample of 11 observations is selected from a normal distribution. Remember, the t-distribution has almost the same characteristics of a normal distribution. So here we have a sample of size 11 observations is selected from a normal distribution. The sample mean was 407 and the sample standard deviation 6. Okay, great. Using the 0.01 significance level is an alpha, therefore here alpha is equal 0.01. Now, we have 3 questions concerning this problem. The first one says state the decision rule. We have to state the decision rule. The second one, compute the value of the test statistic. The third, C, part C, what is your decision regarding the null hypothesis? We have already talked about, how to calculate the critical value from the T table. This is a simplified version of the T table that we discussed just a while ago. Some problems concerning how to calculate the T value. Now, part A, state the decision rule. So what we do here, the decision rule, of course, notice that the alternate hypothesis does not state any direction. Here, if you look at the null hypothesis as well as the alternate hypothesis, we see that we have a two-tailed test. Since the alternate hypothesis, there is no any direction, whether it is greater than or equal sign in the alternate hypothesis. Therefore, we have a two-tailed test. Okay, so therefore, the decision rule is stated by finding the critical values, the critical T values from table B2 in the appendix, and this is a simplified version of the table in the appendix. Okay, now I have already talked about how to calculate the critical value. Of course, since we have a two-tailed test, of course, remember, alpha is 0.01, so half of alpha is located in the upper half, in the right tail, and then the other half of 0.01 is located in the other lower half. So as you can see in the graph of the normal distribution here, so we have alpha over 2 here, 0.05, 0.005, and then over here alpha over 2, 0.005. This is the rejection region. Okay, now we need to calculate the critical value. First of all, we have to go to this table, to the far left column of this table, which is labeled or designated by DF, degrees of freedom. Okay, remember, we have a sample of 11 observation. So the degrees of freedom is going to be n minus 1, as we stated here. Degrees of freedom n minus 1, we get 10. Okay, so since it is two-tailed test, then as I said, half of the alpha is located or is placed in the upper tail of the curve, and the other half is in the lower tail of the curve. Okay, now we need to calculate the T critical. So how we do? First, we go to the far left column here, and it is, we have 10, 11 minus 1, 10. So the degrees of freedom is 10 is here. Now, since we have a two-tailed, now we go and, of course, go to the row corresponding to the appropriate degrees of freedom, which is 10. This is the row we're talking about. This is, the row, we select the row corresponding to the degrees of freedom, which is this row. Now, we move to the, since we have a two-tail test, of course, we move to the portion labeled two-tail, which is this one here, two-tail test, okay? So we select, we choose the column of the selected, significance level. The significance level is 0.01. Remember, in the Z table, we used to take half of this, okay? We used to take half of alpha, 0.05, subtract that from 0.5, and then, find the critical value corresponding to the difference between 0.5 and 0.05. Here, we don't do that. Here, the alpha is still the same. However, it is half of it located here in the upper half, and the other half is located in the lower half. However, when we use this table, alpha is still the same, 0.01. So alpha is 0.01. So what we do, we go to the, to the portion of the two-tail test, which is this one here. Then we go to the column, label the column of the selected alpha, 0.01. We look here, 0.01. It's over here, 0.01. So then we move down, okay? We move down until it intersects, the row with that correspond to the 10 degrees, which is over here. Okay? This is the value of the critical t-value. This is the critical t-value, 3.169. So 3.169, this is the critical t-value, which is here, 3.169. Remember, we have two-tail tests. So the right one, we put the positive 3.69, and the left one, we put the negative of 3.69, because we have two-tail tests. So 3.169 is located here in the right tail, and minus 3.169 is located in the left tail. So we put that one here, okay? Whenever you have two-tail test, of course, the T critical is going to be the positive one, the positive T is located in the right tail, and the negative T is located in the left tail. So now we have the key T critical over here, okay? Now, of course, as we see, therefore, the decision rule is reject. This is, he said, state the decision rule. Therefore, the decision rule is reject the null hypothesis and accept the alternate hypothesis if the computed T value, the computed T statistic value, is not between minus 3.169 and 3.169. If the T calculated value is not in either area here, okay, is not between these two values, 3.169 and minus 3.169, then of course we have to take a decision here, of course. So as long as it is not between these, then we have to reject the null hypothesis. That will be in part. Now part B, as you see here, it says compute the value of the test statistic. We have a T distribution, so we need to calculate the T statistic. This is the T, the value, the equation, the formula of the T statistic. T is equal x bar minus mu over S over radical n. S is the sample standard deviation, which is used to estimate the population standard deviation. The population standard deviation is not known, so we have to estimate it with the sample standard deviation. So we plug the numbers here, we come up with 3.88. Okay? Now, 3.88, as you can see, this is the value of the test statistic. Now, What is your decision regarding the null hypothesis? Now, as you can see, 3.88, the null hypothesis that the population mean is 400, okay, is rejected. Why? Because the computed t of 3.88, that's computed value of t, 3.88, lies in the area to the right of 3.169. It is where? It's located here, inside this area, to the right of 3.169. So it is in the rejection area. Therefore, we reject, the null hypothesis, of course, that the mean is equal to 400. Now we move to solving problem 2. Problem 2, like problem 1, talks about the t-distribution. Why? Because the sigma, or the standard deviation of the population, is unknown. Besides, the population is normally distributed. Now, problem 2 says, in the US, the average annual salary of restaurant manager is $50,000. A human resource manager at KFC wants to see how this compares with restaurant managers with his company. He wants to compare the salary of restaurant managers in the United States with the salaries of managers in the KFC company. He checks the salaries of a sample of 8 managers. So he takes, the salaries of 8 individuals, 8 managers in the company. So the sample size consists of 8 people, 8 managers, and finds the average salary to be $55,000 with a sample standard deviation of $5,000. If the population is normally distributed, this is one characteristic of the distribution, the t-distribution, is that it should be normally distributed. Use the 5-step method or procedure. Can he conclude that the restaurant managers in his company make more money than the US average using alpha, or the level of significance equals 2.5%? Okay, now, the 5-step procedure, of course, consists of the 5 steps as you see here. The first one, we have to state the null hypothesis and the alternative hypothesis. So we state H0 and H1. Of course, since he concluded that the restaurant managers in his company make more money, greater than the average salaries of US managers, then the alternative hypothesis is going to be mean is greater than $50,000. So this is the alternative. So the null hypothesis is going to be H0, H sub 0, is that the mean is less than or equal $50,000. Okay, now we have to select the second step to select alpha. Of course, alpha is given 2.5%, which becomes 0.025. The third step is select the test statistic. Now, of course, the test statistic in this situation is the t-distribution test. Why? Because we have a normal distribution, and then the sigma is unknown, so we use the t-distribution, the t-test. And the t-test, of course, as you see, is calculated as is equal, the formula of t is equal x bar minus mu over s over radical n. Of course, s is the sample standard deviation, is used to estimate the population unknown standard deviation, and x bar is the mean of the sample, and the mu is the population mean, and n is the sample size. We have here 8, of course, managers. Sample size consists of 8 observations. 4, formulate the decision rule. The decision rule, of course, we have to calculate the T critical. So when we say formulate the decision rule, we have to calculate the T critical. How do we calculate it? I have already talked about it in many, problems before. Of course, we have this simplified version of the D distribution, T table. Of course, all we have to do, of course, we find first the degrees of freedom. We go to the far left column of this table, the column labeled or designated by DF, degrees of freedom. Of course, we choose, of course, 7 as this is 7. And then, of course, we choose the row corresponding to this degrees of freedom. This is the row here. This is the row. Okay, now what we do, of course, since we have a one-tail test, we have the one-tail test. Okay, we go to the portion of this T table labeled one-tail test, which is what? This is one-tail test. This, we go to here, and then we move to the, to the column, okay, of the selected level of significance, which is what? 0, which is, of course, which is 0.025. So 0.025 is here. So what we do, we move down, okay, all the way until it, intersects the row that correspond to the degrees of freedom 7, and we come up with what? This one over here. Okay, this is, of course, this is, of course, the T critical 2.36, 2.365. This is the T critical. And remember, because we have a one-tail test, then this T critical is going to be, in the right tail. In the right tail, something like this here. In the right tail over here, okay? So this is, we say here, 2.365. And this is the T critical value over here, okay? And any value that is greater than 2.365, then it is in the rejection region, okay? So we know now it is in the upper tail or the right tail of the T distribution or the normal distribution here. Now, of course, what is the decision? Of course, the decision is to reject S sub 0 if T statistic that we're going to calculate using this formula is greater than T critical. The T critical is 2.365. 2.365. If the T statistic we calculate using this formula is greater than 2.365, then we reject the H sub 0, the null hypothesis, and what we conclude that, the mean is greater than $50,000. Okay, let's calculate the T statistic. We come up with, of course, is equal to 2.80. Of course, 2.80 is greater than or falls in the rejection region here. 2.80 falls in the rejection. This is 2.80 here. It falls here. It's greater than 2.80, greater than 2.365. Therefore, it's located in the rejection region. So we conclude, therefore, we reject S sub 0 and conclude that mu is greater than $50,000. 50,000, of course. Okay, now we move to problem 3. still we are applying the concepts of the t distribution. Statistics instructor believes the mean score on the first statistic test will be at least 65. Okay? Now here randomly samples 10 statistics students scores and obtains the scores 62, 54, 64, 58, 70, 67, 63, 59, 69, and 64. So he got 10 scores from 10 students who are taking a statistics course. Assume the population of a test score is normally distributed. Okay? And we know that the t-distribution has the same characteristics as the normal distribution, so it is also normally distributed. Compute the sample mean. Of course, the sample mean, as you can see, is calculated using this formula. X bar is equal the summation of all the scores over the total number of scores. We have 10 scores divided by 10, we come up with 63. This is the sample mean. Now, to calculate the sample standard deviation, we do the following. Remember, we did that before. We repeat that again here. As you can see, first we put the scores underneath each other. This is X, and then we put X bar. The mean of those 10 scores is 63. Then we do what we do. We have a heading of X minus X bar. Of course, underneath this one, we just subtract X bar from each X. We come up with those numbers, minus 1, minus 9, all the way to 6, to 1. These are the difference between X and X bar, of course. As you know, the sum of those, X minus X bar is always 0. Now, we move to the fourth heading, X minus X bar into square. So we square all those values, and we come up with, of course, their summation is, 226. Okay. Now, to get the sample standard deviation, it is the square root of the variance, which is the summation of all these over n minus 1. We come up with 5.01. This is 5.01 is the sample standard deviation, which is obtained by squaring the variance. Okay. Now, part B says use the 5% significance level to test whether the mean score is at least 65. Use the 5-step method and to conclude. Now, of course, we begin with the first step, state the null and alternative hypothesis. Now, as you said, the claim now appears in the null hypothesis. The claim can appear in the null hypothesis if it is greater than or less than, or greater than or equal, or less than or equal sign. So here, because we have to test the mean score to test, because we are using the 5% significance level to test whether the mean score is at least 65, that is, it's greater than or equal 65. So the claim now is appearing in the null hypothesis. Okay, this is the claim, and since it is the mean is greater than or equal 65 or at least 65, then the alternative hypothesis is going to be contradictory to it, which is less than 65. Okay, now we move to the second step, which is to state the level of significance alpha, which is already stated here, 5% or 0.05. Now we move to the third step, which is select the test statistic. Now, we use here the t statistic, of course, because first of all, the distribution of the population of the test score is normally distributed, and second of all, that the population standard deviation is unknown. Therefore, we use the t distribution. We use the t distribution. So the t statistics is calculated using this formula, x bar minus mu over s over radical m. Of course, s is the sample standard deviation, which is used to estimate the population standard deviation, and we come up with, when we plug the numbers, we come up with t stat is equal minus 1.25. Remember, remember here that the alternative hypothesis is mu less than 65. So the rejection region is going to be in the left tail. It's going to be negative. So whatever value we calculate, whatever value of the t critical we calculate, we have to use the negative of it because we are in the left tail. So now we go, to formulate the decision rule. Of course, formulating the decision rule is found by calculating the t value, the t critical. So as I already stated in the previous problems, the method of calculating the t critical, of course, the t critical is equal 1.833, of course, which is, we have 0.05, we have one tail test, this is one tail test, 0.05, this one here, okay, we go down in that column of the selected level of significance 0.05, we go down all the way till, the degrees of freedom, which is 9. Degrees of freedom is 9 here. Remember, the degrees of freedom here is equal 10 minus 1 is equal 9. Okay, so here, of course, the intersection of the column coming from the level of significance 0.05 and the degrees of freedom from the column degrees of freedom 9, we come up over here. Okay, so the t critical is 1.833. Because we are in the lower tail or the left tail, then here we use, it is 1.833, so we say it is minus 1.833. So it's going to be like this. Okay, it's going to be here. It's going to be minus 1.833, and this is the critical range. Now what we do, we compare the t statistics with the t critical. Now with the t statistics, it is minus 1.25. Minus 1.25 is over here. Minus 1.25. So it is in the H0. It is in the null hypothesis. It is in the region of the acceptance region of the null hypothesis. Here we say do not, in this area, do not reject H0. So since minus 1.25 is not in the rejection region, this is the rejection region here. Rejection region. Since minus 1.25 is not in the rejection region, therefore we do not reject H0. Therefore, we conclude that the mean score is greater than or equal 65, or it is at least 65.